In this video, we will talk about Cerdik C Library. First, please proceed to I2C Labs website. In I2C Labs website, please proceed to Products tab, then KNN Shield. In KNN Shield page, please download the C Library folder by clicking this red button. Next, please agree EULA and click Submit button. At Downloads folder, extract the Cerdik C Library zip file, then open the README Markdown file. Please follow the steps in README file to build prerequisite library c-periphery. First, please search the link at search engine. Download c-periphery master zip file by clicking green button in this website. Please extract c-periphery master zip file at Downloads folder. Open command prompt and navigate to the c-periphery master folder destination. Next, type the commands to build c-periphery. In some cases, additional step is needed to build the library in USR. Please go to line 5 of CMake, install CMake file, change USR local to USR. Save the file after modify the line 5. Cerdik Shield v2 can be directly stacked on top of Raspberry Pi as their pin assignments are matched. You will need to connect them by putting Cerdik Shield v2 on top of the Raspberry Pi. Next, connect the micro USB port of Cerdik Shield v2 to the USB port of Raspberry Pi. Connect HDMI cable and power supply to the Raspberry Pi. Plug the power supply into the power outlet to turn on the system. To connect Cerdik Shield to other Linux embedded board, you may refer Cerdik Shield v2 pinout in docs to Cerdik C Library documentation and your own Linux embedded board pinout. Make sure these few pins must be connected to your own Linux embedded board. This is the wiring connection example between Cerdik Shield v2 and Raspberry Pi. For integrating Cerdik C Library into the system, there are two example codes using different communications to transfer input data into Cerdik Shield v2. Cerdik Demo USB-C is using USB communication, whereas Cerdik Demo SPI-C is using SPI communication. In this video, we will be using Cerdik Demo USB-C for demonstration. There are few things that need to be modified according to the Linux embedded board assigned by user. First, I2C, SPI, GPIO and USB serial port device path must be specified. Next, assign GPIO pin number in green color according to user-own used board. Train, class and test text file path must be specified according to your own input data. Threshold, distance type, row size, column size and K value must be specified too. Please navigate to Cerdik C Library to demo folder destination in command prompt. In command prompt, compile the code by entering. Next, execute the code by entering Cerdik Demo USB. If you are using SPI communication, compile the code by entering in command prompt. Then, execute the code by entering Cerdik Demo SPI. You may check the result with result example txt file in input data example folder. Please visit the link in the description below for more information. Thanks for watching. Bye.